Hey everybody, this is Larry. This is day 29 of the Leetcode challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one, and also we have the weekly challenge. I'm still in San Salvador. No intro today, and apparently we did this problem at some point, and recently enough that it still had it. Why? Why was this a thing? It's been like a year. Why would that be in my cache? I guess I don't know, whatever. But in any case, yeah. No intro today because I just kind of returned the car and walked around the city. Maybe I should have done one anyway, but I forgot and got lazy. So yeah, let's take a look at today's problem. We have 1639. To make sure my table doesn't fall down because that would be really not good. Anyway, today we have 1639. Number of ways to form a target string given a dictionary. Alright, we have some mod things, so let's do the mod thing before we forget. Right. And then here, okay, let's read. Target should be formed from left to right. Okay. To form, you can choose the cave character of the, what does that mean? To form the I character of target, you can choose the cave character of the J string in the word with target I. Man, that's not readable. I mean, I'm sure it's correct and it's very precise, but it's not readable. To form the I character, I'm going to drink some juice while. Okay, I mean, I think I get it. Sorry if you were trying to read it alongside me. Basically, this A could just mean that it is yeah. Basically, if you choose an index, then you can use anything to the left of it for any string, and then you can choose any way you want, right? That's pretty straightforward, honestly. In terms of understanding, right? So here, I guess these are dynamic programming week this week. So we have something like, and again, my apologies. This week is going to be the week that I'm a little bit lazy and tired on. I'm just kind of pooped, frankly. So my explanation is going to be a little bit weaker. I mean, I do have a video from a year ago, so that it isn't that long ago, so hopefully that is better if this is not good enough for you. But yeah, but we have to, there may be just like a count thing where we have an index, which is straightforward in terms of understanding. Well, there are two indexes, right? There are word indexes and then the target index. So maybe word index and target index, right? Is that good enough? I think so, right? You can actually be a little bit smarter about this, but that's fine too. Because the thing is that for word index, then now you can do something. Well, t index is equal to length of target. Let's just say t, then we return 1 because then we are done, right? T equal length of target, n is equal length of words, right? Otherwise, if w index is equal to n, then we return 0, right? Okay, and then this is again another tick no tick situation, I believe, right? Tick is just, well, we find a word in which, and you can optimize this. I'm not going to optimize it yet just because that's not prematurely optimized, but we can say for I in range of n, right? So if word sub I of the word index is equal to target of t index, then now and we want like a total for a count, right? We want total, we want to add it by what is that recurrence, right? Well, we increment the index, the win index, and then we increment the index, and that's it. That's really it. You may want to just mod things for fun, but that should be good. And those are auto ticked, right? And then the no tick is going to be for no, it's just no tick, right? So so then now we do w index plus 1, but t index we do not increment by 1, and that's it. And we return total, and yeah, and then the thing is going to count of 0 0 mod, and I think we're pretty good. Here again today I'm not going to go over memorization. All we need to know is that w index goes from 0 to n, t index goes, oh sorry, this is actually not true, 0 to l, where l is the number, oh actually n is the number of words. So actually I messed up here, right? if they should all, do they have to all have the same length? Okay, then actually L is equal to the length of the first word say, but they all have the same length, right? So actually win index is going to be 0 to L, right? And then T index is going to be 0 to T, and of course what's the complexity here, right? So that's L times T, number of inputs, and then O of N per is the work per input. So total complexity is going to be O of L times T times N. Is that fast enough? I don't even know. 1,000, that's not going to be fast enough, it turns out, right? I mean, I'm going to submit to kind of show you, right? I mean, I don't think that's, you know, or maybe I guess we could have just ran. I hate this new UI. It doesn't save what I did yesterday, right? Like now this is back up to here, and it should time out because of what we said, right? So then now the question is, how do we optimize? Maybe I should have just put in a very long case, but you know, why when they could give it to you, right? I'm a little bit lazy, that's why. But yeah, so this times out, and because we did the complexity is 1,000 times 1,000 times 1,000, we knew that that was going to be the case, right? I mean, it's not that unreasonable. I mean, if it passed, it would have been weak cases, right? So then the first thing to notice is that, well, this part is a little bit whatever, right? Like we know all the words that happens, and actually there's no decision here. There's no changes, no mutation or anything like that. It's just that if this is the case, you count this. So another way to say it is that if you kind of look at this for loop, then what it means, what does it mean? That means that we just have to count up how many times this is true. And this is true if, yeah, you're just gonna count the number of things that this is good for, right? So then, yeah. And you can even like, if you really want, you can actually just be a little bit like, there are ways you can kind of pre-process it if you like, right? Meaning like, yeah, you can be very smart about the pre-processing, but sometimes you can also just be a little bit lazy of the pre-processing, right? You can just do, okay, get rid of this loop and be like, yeah, let's just say get count. I don't know. We all use count, so it's kind of terrible. Times of W index T index, right? And then now your get count could very well be so W index T index. This get count could just literally be the same thing, which is you have this thing, right? Like we're literally copy and pasting. So count is equal to 0, count, and then return count, right? And that's it. And of course, like I said, you could kind of pre-compute it or something. But actually, well, first of all, does it run? The answer is no, because this still does the same thing, right? Like we haven't changed really anything yet. But the magic is that you can actually just add a cache here. Excuse me, gee. I want to say the reason why this works, though maybe on Leetcode it still doesn't work because Leetcode is silly. The reason why this does work, this should. Did I mess up something? I think this should work, right? The reason why this should work is because all of these get summed up in the same price. But I guess this is actually, I lied. This is still 1,000 times 1,000 times 1,000. So you have to be even smaller than that. Right? I guess that was wrong. Yeah, I guess I was wrong, actually. But yeah, there's still fireworks going in the background. But yeah, I mean, the way to do it is just figuring how to pre-process. And the key thing to note is that you can pre-process it in one of two ways, really. No, I mean, you pre-process on actually, I mean, you can, but yeah, it's just getting this thing, you go to this thing, right? The number of characters is the case. So maybe another way to think about it is that this is a character, right? And then, yeah. And then now instead you have target of and then this you just have C, right? And it may look very subtle, and it is, right? But you can see, but as you can see, that is already, well, I don't know if this is ultimately fast enough, but that's, you can see that this is a very minor fix, but it already changes things. What that does is that now the input, instead of 0 to L, 0 to T, now you have C is actually 0 to 25, or technically speaking, more like A to Z, right? And as a result, this only has 26 things, right? So 26 times L is what, like, you know, this is 1000, the other is 26. Here, this for loop is also 26, but and oh, sorry, this for loop is O of n, also 1000. So this is going to be fast enough, or faster, maybe not fast enough. And then the other ultimate way of doing it is that now you can realize that all these are kind of done in parallel, so you can actually just, you know, well, let me submit. I don't know if this is fast enough on Leetcode, but give it, if it's fast enough, yeah, if it's fast enough, you can see that it takes 3.5 seconds, but you can actually even get a little bit better. You can just say get you know, this thing, oops, and you know, maybe you could have a secret, right? And then it's just the C of words of I sub index to do increment by 1. This is very standard, just like getting a frequency table, right? Or let's just say F of frequency table, right? Except that this is cached, so, and here getting it cached means that you have one thing. So then now you can just check this, and that's it. Because then now you do all the things in parallel, but I have the parents right anyway. Yeah, because then now you do all the counting in parallel. Word is not, oh, whoops. Yeah, let's give it a submit, see if it's faster. 3.5 seconds the previous, and now we cut it down to 2 seconds, right? And the reason is just because now we do all the counting at the same time, because before you can, if you kind of unroll everything, you could think of it as like a for loop on the A to Z, and then for each one you go for all of n things. Here you only go from, there's no more this, so then now there's only O of L things, and then O of n each work, so then that's L times n, which is only 1,000,000, 1,000 times 1,000. Anyway, yeah, that's pretty much it. That's all I have for this one, really. I don't know if I did an okay job of doing it. I kind of try to show you different ways to think about it as well. I'm trying to look at this UI is so stupid. Like what is this? I just want to see my old code. What's going on? Just show me my old code. What is all this junk? Oh, this is my old code. But like I can't even look at it in one thing. This is like all over the place. Like like how is there no other way to look at my old thing? Like what is going on? Oh, I mean, I guess it's this, except even then you have to click on view more. Why is there so much stupid junk on this thing? What are these check marks anyway? I don't know what that means, but okay. I mean, in any case, yeah, last time I basically did the same thing, except I pre-processed. So yeah, I think that video looks better. I mean, the code looks better, so I probably said the same thing mostly. So let me know in the comments how you think, what you think about this one. Let me know what you think. The UI is terrible. I almost want a refund because I didn't pay so that I can, like, you know, do all this stuff. Like this is silly. Like they can't like, can they change that on you? Like, you know, after you pay for something? I don't know. Anyway, that is all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later. Take care. Bye bye.